to you for a second here. You have created new functions by using algebraic operations in previous courses. Suppose you want to calculate the cost to air condition your Florida home on a particular summer day. The cost for the cool air will depend on the average daily temperature, right? So how much your parents spend on their electric bill is different in the hot summer months versus the cooler winter months. So the cost depends on the temperature, okay? And the temperature will depend on the day of the year, right? The temperature is hotter in the summer, so your bill is higher. So there's like several variables in there that affect the cost of air conditioning your house. So the process of combining functions so that the output of one function becomes the input of another is known as composition of functions. And you'll see the notation here, in these math classes, especially this one, there's all kinds of notation and having to know what different things mean and be able to interpret it properly. The way you would say this is f of g of x, and this means the same exact thing, f of g of x. So these are completely the same. That little open circle there is not an O, it means the word of. So it's f of g of x, okay? You might have called it fog problems back in Algebra 2 and stuff like that. And so a couple different things I want to tell you before we do some examples is that order matters, and the order that we work these problems is always right to left, which goes against everything we do in this class, really. We always read a graph left to right and that kind of thing, but it's not something that really people mess up on typically, especially after we go over it all. So for example, what you're doing is, normally you just have like f of x. So what this means is g of x is going to be the input into the f of x function. You're going to take g of x and plug it into f of x. That's what you're doing. You're taking it could be a number, it could be a whole equation, and you plug it into the other equation. And you always go right to left. The letters can change. F and G are the most common ones, but you'll see all the letters, okay? Now there's a sentence here at the end that I didn't read because it just sounds really crazy, but it's not difficult once I explain it, I don't think. We are going to be asked in some of these problems, what is the domain? And a lot of times we've had restrictions on domains. There's certain situations where you say x can be anything except that number or that number or that number or those numbers, okay? And those situations in these problems will come up with these type of problems. That's a rational function. Remember a poly on top and a poly on the bottom? It doesn't have to be exactly like this. I just mean an x in the denominator of a fraction. We know that we can never have a denominator equaling 0, right? It can never equal 0. So if there's a fraction in a problem with an x in the denominator, you have a restriction on your domain, a value or values that x can't be. And the other situation is in a square root. What are we not allowing under a square root? Can you put a 4 under a square root? Yes. Can we put a negative 4? No. Remember I told you we went over imaginary numbers, that we only worry about imaginary numbers, i's, for this one section, and then going forward we only deal with real numbers. So you can never have negatives under a radical, a square root, okay? Can you have a 0? Can you do the square root of 0? Yeah, 0 is fine. And if you ever forget, ask your calculator. If your calculator allows you to do it, it's okay. It will give you an error on a negative number, but if you put the square root of 0 in, it'll give you 0. So when we have a x under here, we just know that x has to be greater than or equal to 0, okay? It can be 0 or anything bigger. That is a way of excluding negative numbers, okay? So I'll cover that when we get to that example, all right? So let's do our first example down here, example 1. We're going to do f of g of x and g of f of x. So it's two different problems. The order matters. So f of g of x, g of f of x, okay? So, and they gave us f of x and g of x. They're both linear. There's no fractions, no radicals, so there's no problem. I say that a lot. If there's no fraction, no radical, no problem in the domain, okay? So this one doesn't ask for the domain, but no matter what, it's going to be all real numbers because it's all lines, okay? All right, so we start right to left. So we're going to take the g of x function. here it is. G of x is this right here. That's what g of x equals. We're going to take that, whatever's in that box, and plug it into the f of x function. Where do you think we're going to plug 4 minus x in? Always for x. If there's more than one x, which we'll see in a minute, you'd plug it into both places. If there were 10 x's, you'd put that 10 different places, okay? Anywhere there's an input spot, which is x, we would plug that whole function in, okay? So that's 3, right? Take out this x, plug 4 minus x right in its spot, and then there's a minus 5. So take a look at that. I just grabbed that, scooped it up, plugged it in, substituted it in for the x. And the rest of this is just algebra. Simplify that expression. It's not an equation. We're not solving for x. We're just simplifying it. So, of course, we're going to distribute and then combine like terms. 12 minus 5 is 7 minus 3x. And you could absolutely write negative 3x plus 7, the order. There's no rules about that. So that's fine. Okay? So let's see how, even though it's the same two functions, the order changing will make a difference. So here we're going to take all of f of x and plug it in to g of x. So I'm going to take this whole thing right here, that whole thing, f of x, and plug it in to the other equation. And of course, it's going to go in right here, right? I'm going to put this whole thing there. So that would give me 4 minus, now this f of x is a binomial, right? It's not a mono. If it was just an x or a 5 or a 4x, a single term, I wouldn't need parentheses. I could just write 4 minus 4x or whatever it is. But because it's a polynomial, binomial specifically, it's 2 terms, don't forget that that minus is going to get applied to the whole binomial, okay? So you don't want to forget that you would distribute that negative to both of them. Very common mistake right here is just to do, this is wrong, 4 minus 3x minus 5. That's a very common mistake. They'll just plop the 3x minus 5 down and not remember that that negative goes to both of them. Okay, and then 4 plus 5 is 9, minus 3x, or negative 3x plus 9, either way. So you can see how your answers turn out differently. Differently? Okay, so, all right, let's do some that are going to have some domain restrictions. I'm not going to make us do all of these. We'll do B and C. Okay, so the directions, they give us f of x, they give us g of x, they give us h of x. Okay, f of x is a quadratic. It has no domain restrictions. X can be anything it wants. Okay, there's no fraction, there's no radical, so there's no problem. Here, we do have an x in the denominator, so we will have a restriction on our domain. And we have a radical here, so we'll have a restriction on its domain as well. Okay, so let's see what they're asking us to do. They're saying take f of x, plug it into g of x. Right? So I'm going to take this whole thing and plug it in to g of x. G of x has one single x right there. Okay? So that would be 1 on top over, I take out this x, I plug the whole f of x right in that spot. So x squared minus 3x, and then plus 2. And simplify it. Well, nothing else to simplify. There's no like terms to combine. There's not a fraction to simplify. That is f of x plugged into g of x. Now, it does ask for the domain. So we do have a fraction here. So we have a problem, all right? There are actually 3 numbers that x cannot be, okay? And then I'll go over how to write the domain. Back to the original problem, f of x and g of x, okay? Look at g of x. Wait, let me think about this for a second. That into that. Okay. So here's what you have to check, okay? It's actually only 2 numbers that x can't be. Anything that makes this fraction a denominator a 0. Here's what's confusing, so please listen to me carefully. f of x had no restrictions, right? F of x was fine. When we plug it into g of x, it's going to change g of x, so we don't have to worry about this denominator, since it was the second one, since it was the one, what we call on the outside, that got plugged into. But if these had been flipped and I was plugging g of x into f of x, I would have had to go back to the original one that I plugged in and say, oh, x can't be negative 2. Let me go over that another way with our next example. Okay, so let me say that better in a minute. Let's just for now say, what is it that x can't be in this problem? And to know that, we have to factor, okay? We have to know what these x values are. So the two numbers that multiply to get 2 and add or subtract to get negative 3 would be negative 1 and negative 2, right? So what is the number that if I plug it in right here would give me a 0? 1. And if I plug in right there, would give me a 0, would be 2. So these are my domain restrictions. Those are the two numbers that x can't be. And we're going to write this in interval notation. So your domain will be from negative infinity to 1, right? But not including 1. We jump over it. Remember how I like to call that like jumping over the number? Get back on 1 again and go all the way to, what am I going to write here? 2, yeah. Radicals. Yes. No, 0 is fine. If you put a 0 right here, you'll get negative 1. If you put a 0 right here, you'll get negative 2. So understand that this means in this situation, x can't be 0. Our denominator cannot. The denominator can't be 0. Okay, so I'm glad you said that, Zoe. So, because I know a lot of students just think that that means, oh, whenever I see a fraction, 0 is a number that x can't be. No, it just depends on what's in the denominator. It means, like, if this was my denominator, x can't be what? Negative 3. Because that can't equal 0. The denominator can't equal 0. So I'm glad you said that. Right? And so then I skip over the 2 and I go to infinity. So remember, we've done this with like asymptotes and stuff. That's just a way of showing that everything but the 1 and the 2. Okay? Now, let's do this next one. H of x into f of x. So, let me use a different color. I'm going to take all of h of x and I'm going to plug it into f of x. But look, guys, f of x has 2 x's. So I'm going to put it into both x's. So I'm going to have the square root of x squared, right? That's that guy right there. Minus 3 times the square root of x. I can just put them right next to each other. If you already wrote parentheses, that's okay. We have to simplify it one more step. Negative 3 times the square root of x is negative 3 square root of x. Okay. What happens when you square a square root? Cancels, left with just x, and there's absolutely nothing else to do here. Okay? Now, we have a radical in our answer, right? No fraction, but we do have a radical. We know that whatever's under the radical has to be greater than or equal to 0, which means x has to be greater than or equal to 0. How do we write that in interval notation? So that's 0 to infinity, right? From 0 to infinity. What will we put on the 0? A parentheses or a bracket? A bracket. Second period was kind of confused by that, so let me just make sure everyone understands it. Because x can be greater than or equal to. So remember, if there's an equal to, that's including the 0, which means a bracket. Now, what I was trying to explain to you guys before was this. When I plug h of x into f of x, I still had a radical left in my answer. So it kind of covered us. But listen, if h of x plugged into f of x had just been this. Let's just pretend. Look, let's pretend f of x was just this part. So when we simplified that, we got just x. Okay? So let's just pretend that that's what happened, that there was no minus 3 or whatever. Because h of x was a radical, you would still have to use this as your domain. Because you would never have been able to go forward had there been a negative number in the domain. Like in the very beginning, you still can't have a negative number in h of x, because then you would have an imaginary number. You wouldn't be able to plug that into f of x. But if it were flipped and it got resolved, that's okay. It's only the first one that you plug in, the original, that you have to make sure is covered over here in the restrictions. Am I making sense? Hopefully I have another example to show you. Okay? So let's just say it like this. When you have to look at your domain, look at your final answer, of course. Is there anything there that's causing a problem? And there was. And you have to look at whoever you started with, h of x. Okay? So if this radical had been resolved somehow in the work, we still would have had to acknowledge that before it got resolved, it was a radical, and this would have had to be the domain. Okay? Why didn't I do that on this one? Almost done talking about this. F of x was the original one that I plugged in. F of x had no problem. And then g of x got taken care of, resolved, and we still acknowledged what the denominator couldn't be. But you don't have to worry about it from the original standpoint. Okay, so it's only your final answer and what you plugged in. Okay, now let's do some ones with a graph. I think these are easier. Okay, look at what the language is. Okay, we have two graphs, and guys, graphs are just points, right? X's and Y's, and we have one called f of x and one called g of x. You just follow the path. Watch, right to left. G of 3 plugged into f. Why isn't that an x? Well, because we're talking about points now. G of 3. G of 3 means what is y when x is 3 on the g graph. Okay, so if I go to the g graph and I go over to x is 3, y would be 1, right? So g of 3 is actually 1, right? So I'm going to plug 1 into f. Now go to the f graph, f of x, right? 1, when x is 1, y is 2. So 2 is your final answer. Yes? Yep. Because we're only doing real numbers now. So unless the directions say something about imaginary numbers, that's why I said when we did imaginary numbers, we did it for like just that section, and I said we won't talk about it again until the exam, because most of the time in algebra, we're just dealing with real numbers. You're right, we could simplify it with imaginary, but just we're only working with real numbers. Pi squared. What? Right, but you're not squaring this number. Well, you're not squaring this number. Yeah, but to start with, if this is what you start with, so this is your h of x, what can x not be? X has to be greater than or equal to 0. It has to be. So we're just talking about real numbers here. We don't know what we're plugging into there. That is a fact. X has to be greater than or equal to 0. So if that gets plugged in here and gets resolved, it still, to begin with, never could have been a negative number. That's the rule. Okay? Okay, let's look at B. G of 1 into f. Stay with me, guys. G of x. So go to the G graph when x is 1, y is 3, right? G of 1 equals 3. So let's write it neater. Now we want to know what f of 3 is. When x is 3, y is 2. Just coincidence there. Keep going. So look, this looks really complicated with all the symbols, but it's really just simplify this one, and then multiply the two numbers together. So let's just start with this one. G of 4 into the f function. So remember, this is g of x. So in the g function, when x is 4, y is 0. So now I have f of 0. In the f function, where x is 0, y is 4. So we simplified this whole thing to 4. And we're going to multiply it by whatever we get over here. F of 1, so in the f function, when x is 1, y is 2, right? f of 1 is 2. So g of 2, go to the g function when x is 2, y is also 2. Multiply them together, final answer of 8. Do you guys have a question? Okay. One more of these. You have a fraction. F of negative 1. There's no composition there. That's just f of negative 1. Go to the f graph. When x is negative 1, y is what? Yes, 6. G of 3 into the f function. So when g of 3 is 1, right? So now we have to do f of 1. F of 1 is 2. So that whole thing is just 2. And when we simplify that, we get 3. So you just kind of have to follow the path, right to left, make sure you go to the correct graph, and just finish it. All right? Last two. There was a trend in cooking there for a while where chefs were decomposing dishes. Like decomposing a Caesar salad would be like, you guys know what a Caesar salad is. So chefs would like keep all the parts. Guys, can you please stop talking? They would take all the parts of the Caesar salad and separate them, or decompose shepherd's pie. Shepherd's pie is mashed potatoes and veggies and cheese and stuff like that. And instead of making it a casserole, it would be separate. They'd call it a decomposed whatever. Okay. What we're going to do is decompose some functions. What we're looking at is the f of g of x, or like whatever. They already did that. It's your final answer. And what we're going to do is separate it back into the two functions. It's easier than it sounds, okay? So what they gave us is h of x was, we got h of x by doing f of g of x. So g of x is on the inside, right? G of x is on the inside, and we plugged it into f of x, so we consider that the outside. And one way of thinking of the outside is like the parent function, the most basic form. It's not always true, but let me show you what I mean. D is kind of an exception to the rule. But look, so x plus 3 got put into this parent function. Like you can see that that's an x to the second power. And think about it. What did we replace x with? The x plus 3. So we took x plus 3, plugged it in for x, and that's how we got that. Okay? What's the parent function for a rational function? Remember, this is just a fraction with x's in it. That's 1 over x, right? What did we put in place of the x? X minus 5. You can check it very easily. If I took x minus 5 and plugged it into x, do I get h of x? Okay. How about h of x, question C. Can you tell what the outside one would be? Square root of x, right? We took out x and plugged in x plus 2. Are we seeing it? This looks a little bit different, but look, you can see that there were x's right there, right? There were x's right there that got put in the same thing. So that's the x minus 2. That's what got plugged in. What was there before that would have been x squared plus 5. So that's not really a parent function, but it's the parent function really for this purpose. I mean, I'm just using that loosely. Okay. Last one. All right, word problem. I need to write little things to help me understand these. Jim plants wheat on his farm in Kansas. This is kind of going back to the air conditioning thing, that the bill depends on the month, and the month depends on temperatures, all that stuff. Jim plants wheat on his farm in Kansas. The function W of A gives the amount of wheat W in bushels that he can expect to harvest if he plants wheat on A acres of ground. So I like to give myself a little note. That's totally optional. So amount of wheat based on how many acres. That's what W of A is, okay? When the wheat is harvested, so when it's done cooking out there in the sun and they cut it down, he can calculate the amount of money, so M is money, okay, in dollars that he will earn from selling W bushels. So W is how many bushels or number of bushels, okay? I guess I should say number of acres, number of bushels. Okay, so just interpret what this is saying. So the W, that's this one. Whatever's in the parentheses is the A, right? So that's 5 acres equals, and what does W of A mean? Bushels of wheat. So he'll have 275 bushels of wheat. I'm just interpreting W of A. There's nothing fancy going on yet. Okay? So M of 65. So whenever you have an M, the number inside, it told us was W. So W is the number of bushels of wheat. Okay? So 65 is my input, my W. 65 bushels equals, and M of W is money. So $550. Okay? So how do we explain this with a composition? Remember, we start here and go to there. What does W of 4 mean? Well, remember, 4 is the number of acres of land. So 4 acres of land will equal M of that. M of anything equaling that. This is your money. So that would be $2,100. So the work was already done. We didn't have equations to plug into. They're just telling us, when I plugged in 4 acres into the M equation, which we don't even have, I got $2,100. So it's just real. So that's a little confusing. So you have to really read. And like, this does help if you write yourself little notes. Maybe it's just easy for you. I don't know. All right, I'm going to do the first one with you, because it's got 3 parts to it, and I just want to kind of show you a shortcut on a certain type of problem. So I'm just copying it down while you guys are getting to that page. Okay, so let's do number 2 together. There's some stuff I have to show you in here that were not in the notes. Now notice that they gave you 3 problems in one, and I only gave you 1 of these to do. There's 3 problems in one. I'm going to do all 3 with you, and you need to listen, okay? So working right to left, I'm plugging G of X into F of X, right? So I'm taking this whole thing and plugging it in right there. Since it's squared, I'm going to put it in parentheses, right? I have to square all of X, and that is all of it, plus 1. Now, guys, listen, you can go off to the side and FOIL this if you want to. And I have about 50% of students that they don't want to know a shortcut. This works easy for them. They know how to FOIL like a boss, and they don't want to learn anything new. Okay? So you can FOIL like old school, but you have to do this a lot coming up in the next few weeks, so you might want to just learn the shortcut. Here it is. You square the first term. So if I square a 2, I get 4. You square it, and it's going to match this that we did here. The middle term is the hardest one, so listen. You multiply everything together that's in the parentheses. 2 times a negative x. That's how I would read that. 2 times negative x is negative 2x. And then times 2. Because remember, there's always 2 of them in the middle. So 2 times negative x is negative 2x. Multiply that by 2, I get negative 4x. And that's what we got right here. And then you square the last term. Negative x times negative x is positive x squared. That's the shortcut. We'll have it again in a minute, so I'll show you that again. Use it or don't use it. It's your choice. You don't have to use it. All right, and then just clean this up, right? I'm going to put x squared first, minus 4x, and then combine like terms. Could the order have been different? Yes. Okay. And as for the domain, you'll see on my key this notation. Let me just tell you what it is. X belongs to the set of all real numbers. This means belongs to, or is an element of, or you could just say negative infinity to infinity, or all real numbers, okay? On tests and on the AP exam, you should be using interval notation, though. 4 plus 1. Don't forget, you had to plug this in there, square it, but then there was a plus 1. Okay, part B is g of f of x. Plug f of x into g of x. So I'm going to take this whole thing, put it right there. So I'm taking this whole thing and putting it in for x. Since it's more than a monomial, I'm going to put it in parentheses. Right? I just put this right here. Distribute. And so here we have, order doesn't matter, 2 minus 1 is 1 minus x squared, all real numbers, right? No fraction, no radical, no problem. I really wanted to get to this one because some students freak out when they see this. Like, how do you put a function back into itself? How do you put f of x into f of x? Plug it in. Yeah, same way you've been doing it. F of x, okay, look, here's f of x, right? I'm going to plug it right back into itself. So f of x, this mess, gets plugged in right here. So I'm going to put x squared plus 1 here, squared plus 1. Kind of weird. Just follow the process. Scoop up x squared plus 1, plug it in. X squared plus 1 squared plus 1, right? Took the whole thing and put it right there. And here's that shortcut again, if you want to practice it. Square the first term. So x squared squared would be x to the 4th. Multiply everything in the parentheses together, then double it. So x squared times 1 is just x squared times 2 be 2x squared. And then square your last term. 1 squared is just 1. But don't forget, there's this plus 1 also added on the back. This is this. And that is that. Okay, and so there's only one last thing to simplify, and that would be to add 1 plus 1. All real numbers again. No fraction, no radical, no problem. All right, so I wanted to get that one done with you. That was the worst one. I already put the key on Canvas, so if you have your laptop and want to go there, it is already there